Awesome. Thank you very much for coming for this session. I really appreciate. I hope you are enjoying the session. So bonjour for the local people. Um, that's where my French stops. Um, as Mehdi was saying, my name is Hugo. I'm part of the developer advocacy team at Red Hat. I'm a Microsoft contributor. And today we're going to be covering a very interesting topic that I have been passionate for the last 5 years. So we will be talking about distributed applications and connectivity across those applications. We will go over some of the patterns that we have found. As you know, patterns are the way to abstract certain common features in a way that we can analyze them and work with them and replicate them across different, spaces in the application, in the development aspects yours go up across applications, and then we will be doing a quick recap on such. So I was saying, I'm a Mexican based in Massachusetts in the United States. I specialize in APIs, event-driven architecture. I'm an open source advocate and food and travel enthusiast, so glad to be here. There's my Twitter handle if you want to continue the conversation, if you want to follow us or engage. Happy to share experience and what you learn in your own area. So let's start with, in the beginning, like any other movie you can see in a long, long, far galaxy away, we were happy because we have our traditional monolith, we have our single cluster, our single cloud, where we're able to easily find and discover where our application was available. It was a specific IP address or a specific name, a specific service that was well known. So it could be just an API, a database, another kind of service that was available in that specific ecosystem. We was happy, everyone was okay, and we tried to keep as much as possible into that space. However, there were some things coming, and most of them were related to this growth that Mehdi was talking about before. We need to start to work with security and compliance. We need to have a IT agility that perhaps was limited by the current situation. We need to go with a different vendor, provider, cloud provider. We have data gravity. So yeah, you can certainly move your data from one place to another, but how you do transfer of 50 petabytes of information? And perhaps you can move it. It will take a while, but how much is going to cost that? You have geolocation restrictions, geofences, where you cannot get data move out from that place. You need flexibility. You're starting a new business and you're moving your applications to, say, Argentina. So can you tell me how many regions of AWS are in Argentina? And they have strict rules and regulations regarding data sovereignty and governance. So you will need perhaps to go with Azure because they do have a data center there. So these kind of things are the reasons why we are starting to live in this world that has multi-clusters, multi-clouds, multiple geolocations. However, that becomes a nightmare. So if you have seen this movie in the past, you remember you have this little cute thing called Gizmo. It's very attractive, fun, etc. But if you feed it after midnight and you spread some water on that, it just becomes trouble. So this is how I feel that I'm dealing when I need to work with multi-cluster, multi-cloud, and even edge applications, because we have applications going all the way, not just across cloud, but all the way to factory floors, hospitals, or even retail and cars. So we need to cover all those kind of deployments. So the utopic single place where we were talking at the beginning, there's no more. So we're not in Kansas anymore. And this can become complicated when you have service silos. So, okay, I'm going to run in Argentina in Azure, but I won't be able to connect to that with my service that it's running perhaps in Switzerland. My database is running there, and I need to connect. So how do I do that? So there's problems with the integrity of the data. So when I replicate information, I perhaps send a PDF file, a Google Sheet, or I try to do an ETL that goes every other day, or it runs perhaps twice a day. But meanwhile, there's lack of information. If not, you will certainly find that you are building spaghetti code and integration point to point, basically an integration mess. And that's only from the business perspective. But what about the actual topology, the infrastructure side of the house? So first, you have different operating systems. You have different versions and distributions of Kubernetes because AKS, it's not the same as EKS. Even though they're based on the same Kubernetes versions and models, they implement things different because the load balancers from Azure is different from the ones from Google and the ones from AWS. So that's something you will need to work on. And well, that's if you're working with Kubernetes and you standardize on the cloud operating system, but what about your Linux systems, your Windows servers? You're still using Solaris or other kind of Unix systems? Mainframes. So if you're in the banking industry, you certainly have this core banking running on, the tandem machine that has never been stopped in the last 20 years. On the other side, on the connectivity side, you have firewalls, you have networking collisions and conflict with CIDRs, IPv4, IPv6, overlapping networks, multiple administrative domains, and for any developer, your nemesis, the security officer, the people managing the networking. So when you try to implement some patterns to connect your applications in the hybrid cloud, when you need to connect, restricted or secure environments with the public cloud, or when you want to connect edge-to-edge sites, thinking about, your branch locations, retail locations, factories, or even distributed systems, well, those are the kind of scenarios that make it more complicated. At the end, what you really want is to have this application connectivity that it's seamless across all these different landscapes and scenarios. And I have an hypothetical example where you have your database running Oracle RAC in Switzerland. And then suddenly you have used a very old application running in AS400 and 3GL. And it saves orders. It's your partner's application. You haven't really dedicated a lot of time to create APIs for that. They are still using a green screen or a blue screen to save that information. But then you need to, add more capabilities. You need to be able to get the benefits of the serverless functions that are running in Google Cloud. Or you decide that you need to move your data lake to Azure. So how do you propagate and connect those applications together so you have this consistency across all these environments? What you want to do is have this connectivity tissue that allows you to have this order being saved in Oracle, and this triggers a serverless function in Google Cloud. At the same time, it's saving a copy in your data lake for future analysis. So this is what we will try to cover and address in this session. Can we connect these services and clouds together using some repetitive patterns? And I wouldn't be bad, so I will put them all here, and we will recap them at the end. So what we discover after going with customers and reading and working with vendors and partners is that we have a series of patterns that build on top of each other that are most of the times complementary, but you can mix and match. So it depends on how you're going to be using your consumption patterns. So the first one, it's going to be APIs. So APIs, and I think I won't need to go too much in detail, is these interfaces that we can program. And when we're talking about traffic on APIs, we're talking about most of the times, point-to-point kind of traffic, very common on microservices architectures. And the interesting thing here, and certainly the next speaker that is very well known in the service mesh world, will talk about east-west kind of traffic, north-south, interdomain versus intradomain. But the idea is that you have components that allows you to expose your capabilities on a certain way. And this type of capabilities most of the times are relying on things like the gateway, right? So when you want to connect your applications or expose the service of your application, you have a consumer that connects to an API through a gateway where you have your data plane that is implementing the connectivity, and you configure everything on your control plane that is most of the times an API manager. In this way, when you are targeting bounded context or inter-domain communication, you want to have business focus on the APIs. Your API owners are just controlling a business level type of security and control. But however, if you just want to have services and APIs as a base to communicate systems that are spread across different domains, and spread across different clusters, you sometimes rely on things like service mesh, where you also have these concepts of the data plane and the control plane, being the control plane, a way to configure custom resources and Kubernetes or the configuration of the service. And then you have the instead of a gateway, you have the envoy sidecar that is running attached to your application, or you can have a sidecar per node and such. So this is the first pattern, APIs, very well known. The second is the store and forward pattern, and perhaps you know it by a different name. Store and forward is mainly known as event-driven architecture, where you connect in a synchronous way between your applications. An important part here in this pattern is that you start to tackle some of the limitations of network instability and unreliability. So we will have APIs. We know that both systems need to be available at the same time, and I'm able to connect. But the ability of store and forward is that we can decouple in time when those systems are available, because we are introducing this middleman that it's called the broker or the event bus or the event service that allows us to take ownership of the communication and then being able to deliver that communication or that event or that data into the future to the interested parties. So this is the concept of store and forward, meaning that the broker will store the information and then set it. If you go to the diagram here, when you go to a coffee shop, you don't wait for the barista to give you the coffee. They will call your name and say, okay, now it's ready, you can just keep it. So they keep it for you for a moment. So what you see is typical this kind of scenarios where you have your broker, that it's your application connecting to a local broker, and then that broker is transferring the information directly to other applications, or they're replicating their applications. So in this scenario, I think you are using Kafka and Knative, and then you will have some tooling like Mirror Maker to be able to share that information. This is where you have event-driven APIs, where you will be using sync APIs to be able to define the interactions in between your applications and the broker. Technology that we usually use here, MQP, Kafka, cloud events, and such. So this is the second pattern. And the third pattern starts to build and replace some of these components. So we were saying in the store and forward that we have a broker that is running there and is getting the information. But we are cloud native, right? So what we do, instead of a traditional broker, we just use cloud services. So you have used or you have knowledge of that name that is appearing on the building on top. Who of you are using that solution? Who's using Salesforce? Cool, a couple of you. So what you're doing is you're using cloud services. So most of the times when you're using cloud services, that means that you're using kind of the same distribution that you have in store and forward, but you're delegating that to a public vendor, a cloud service, a SaaS offering. So most of the times you have an in-only pattern where you connect your applications to this single vendor, the middleman, that you will receive your information of your data, and then you will be able to query that information from that provider. So it's basically the same aspect, but the benefit of you don't have to manage it, and you will be delegating to somebody else. Here are some limitations of this kind of usage. When you're using a cloud provider, cloud vendor that is hosting the service for you, most of the times the communication wants to be only in, as I was saying, on a secure channel to avoid exploits and hacks and things like that. And most of the times the limitations of this kind of approach, if you're using traditional APIs, it's that the traffic just flows in one way. So the red arrow shows how the traffic flows, the black arrow, how the connection is established. You can have a callback, but it's sometimes difficult because it means that you will need to open an inbound connection from that side to your service. So that could be a risk. So the good thing about cloud services, they're easy to use. Obviously, everyone has used Salesforce connected to them, to S3, to Kafka as a service. Any one of those services allows you to have this storage of data. And you can use inbound connections. You can perhaps do callbacks functions. I I think most of the times, if you are not using a VPN or a secure channel, your CISO won't be happy to have these callback functions. They provide SDKs, and you can go over public or private networks. So that's a way to have this public service, delegate that information into this cloud provider. So this is the third pattern. The fourth pattern we have is the service network. So we're building on top. So we were saying APIs, decoupling with event-driven and broker. Then we replace the broker with a cloud service. And then we have now the service network. Service network is this mesh of infrastructure and connectivity that allows us to have an abstraction layer on top of these connections and physical connections on the side. So what we do is we create this abstraction network on top of your VPC tunnels, your network connections, your VPNs and such, and you create a layer on at the application level on layer 7 to be able to connect those services. So how it looks like, it's that instead of having a replication or a copy of your services in each one of the deployments and just do a load balancing from the network perspective, what the service network does is create a virtualized version of a service that it's available as a local service in one of your clouds or one of your clusters, and then uses the concept of routers that have this mesh to do failover and load balancing of connections from your applications to the actual place where your implementation is actually living. So that means that I have a service running on Azure, but I want to connect from AWS. And instead of copying the service or implementing because I want to get the best of Azure, what I do is just create a stub or a prox service that is a representation of this actual service that I want to connect. I see it as it is local, so I don't need to deal with TLS and things like that, even though the connection is secure across the network, and I can just consume that. So you have seen there's a virtual service that is where we are connecting, but it's actually routing the traffic all the way to the other service. The benefits here is that when you establish this kind of service network, you have the routers creating the connections that can be in only too, but the traffic flow between the different sites, it's bidirectional. So you are able to connect and consume the services in either way, right? You can go all the way to Azure and back, or you can go from Azure to AWS and over. And the good thing about this is that it works with TCP as well as HTTP, so what means that you can still use your APIs in the original story where we just having everything together, because it will look like that even though the implementation is not like that. If you want to do the same thing with store on forward or event-driven architecture, you can also do this kind of things. The idea is to have this abstraction on top of it. So doing a recap, we cover 4 different patterns: APIs, synchronous type of communication, pretty useful to use, a lot of tooling around. Store on forward, event-driven architecture, async APIs. It's caught in the race in connectivity. You have cloud services where you simplify and abstract these solutions where you use your Salesforce account, your S3, your services where you're delegating this into some managed service, and the service network that will allow you to connect between all these different type of scenarios in a more seamless way, and still build on top of that as if you were running on a single cloud or service. So I think I'm getting to the end. So merci beaucoup. Thank you very much. If you have any questions, please don't hesitate to stop by the Red Hat booth, or just stop us if you can see us. My social media and links and such are here. So if you want to connect through LinkedIn, you can just follow on Twitter, read our documentation on developers.redhat.com, or just watch the YouTube channel with some videos and examples of this. You're very welcome to do that. So thank you very much, and see you around.
Thank you, Hugo.